Hello and welcome to this lecture on our dimension node. Our object dimension Python class is designed to interact with Maya's directed acyclic graph node structure and aligning with our own Python DAG structure. This subclass provides functionalities for handling node dimensions, bounding boxes, and positions. Key features include world matrix validation, a bounding box extraction, dimension calculation, and pivot manipulation, and distance calculation between nodes. Dimension node key functionality. Some key functionalities involve the world matrix check, which is ensuring that the node has a world matrix and therefore a shape object with position in the environment. Bounding box retrieval retrieves the bounding box information using the methods xform bounding box, or BB, and this will give us access to the dimensions, width, height, and depth of the node. Positioning and centering, calculating the center or the average of XYZ of an object and returning the world space translation and rotation pivot of the object. Pivot handling, returning the translation or the translate pivot and the object rotation value with additional functionalities for copying and centering the pivot. So the key methods that we're going to be using essentially are width, height and depth, which I'm sure you will be using a lot. These methods allow the proportions of our object to be gathered independently of their scale settings and their hierarchy. The copy pivot from, and copy pivot to methods allow the copying of pivot positions from one object to another, enhancing the flexibility in manipulating an object in the scene. And then centering the pivot just adjusts the pivot to being at the center point of the bounding box. With distance to, calculating the distance between the node and other items that are useful for spatial relationships and dynamics. So why dimensions are crucial? So this streamlines workflows essentially within 3D objects in Maya. The functions like centering, copying pivot, object dimension within object dimensions allow for a smoother workflow in positioning and manipulating scene objects, which in turn enhances the flexibility, offering functionalities to retrieve and manipulate critical attributes of the object nodes from an object base node. This improves accuracy, making sure that methods like distance to provide accurate spatial relationships, which are crucial in all 3D modeling, rigging, and animation scenes and environments. Extendability. As a subclass, object dimensions can be further extended to suit specific needs, thus contributing to a more efficient pipeline and workflow. So here's an example of our dimension node code, which essentially will be accessed using the dot notation O. Again, like with attributes, it'll be quite simple. We only have 2 of these really set up at the minute, which again will make sure that things are readable and that the doc strings on them are clear. So we will essentially, all we'll need to do is create the DAG objects, a sphere or cube, and then to get the distance between these, all we'll have to do is say sphere dot notation object dimension, and then dot notation, or dot for short, distance to cube. And this will just provide us essentially with all the functionality that gives us the distance in world space between these items. And then we can just copy pivots by example, just going sphere.o.copy pivot to, which again we can reverse and just do copy pivot from. But again, all of these little dot notations give us a huge amount of extendability and flexibility within each subnode within our own Pythonic DAG structure. Thank you so much for listening, and let's jump into the code in the next lecture.